This is Mrs. Appiah with Lesson 1 in Grade 8, Module 4, Linear Equations. Writing equations using symbols. Pause the video and copy our essential question. How do you write a mathematical statement using symbols? We have a word description on the left, and we have a numerical description on the right. Which do you prefer, the word description or the numerical description, and why? Well, let's take a look at this and see if we can help you figure that answer out. The number 1157 is the sum of the squares of two consecutive odd integers divided by the difference between two consecutive odd integers. Pause the video and write down which you prefer and why. Personally, I prefer the numerical expression. I like to see the entire equation all at once rather than reading through it a little bit at a time. Let's take a look at example 1, keeping in mind our objective for this lesson, which is to accurately transcribe written statements into mathematical symbols, which would be an equation. So our statement says, a whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. Okay, our goal is to transcribe this statement into an equation. Here are the general steps to writing an equation. We'll pick a variable and write what it represents. We'll identify the operations involved. We'll identify the equal q. And then we'll write the equation. So let's start by identifying a variable and what it represents. It says that a whole number has the property. So let's pick a variable. Let's use x and let it represent the whole number. Let x equal the number. This is called identifying the variable. It has the property that when the square of half the number, well, how would you write the square of half a number? Well, how do you get half a number? You either multiply it by 1/2 or you divide it by 2. So let's take a look at what that would look like. We could do x divided by 2 and then square it. That is the square of half the number. Another way that you might want to do that is to multiply the number by half and then square it. So those are two different ways that you could represent that part of the statement. So we just need to pick one of them. And I think I'm going to use the one on the left. So it says when the square of half the number is subtracted from 5 times the number. Okay, subtracted from, so we're going to take it away from 5 times the number. Well, how do you write 5 times the number? We write 5 times x. And remember, when you have a coefficient and a variable, you don't need a times sign, so we just write 5x. We get the number itself. Well, that is our equal q. What is it equal to? We get the number itself, and the number is the variable x. So this is the square of half the number subtracted from 5 times the number, and we get the number itself. So this is our numerical expression or equation. Let's take a look at example 2. We want to express the following statement using symbolic language. Paulo has a certain amount of money. If he spends $6, then he has 1/4 the original amount left. Remember that we want to pick a variable and write what it represents. We know that Paulo has a certain amount of money, but we don't know what it is. So let's let x equal the amount of money Paulo starts with. That is identifying the variable. Now, if he spends $6, is that going to increase the amount he has or decrease it? Do you add 6 or subtract it? You're right, you will subtract it. So we have the amount of money that he starts with, and then he spends $6. Then he has a fourth of the amount left. So this is our equal cue right here. Then he has a fourth of the amount left. Equals. Now, how do you write a fourth of the original amount? We know the original amount is x. So we could write 1/4 times x, or we could say x divided by 4. So you just have to pick one of those to use. I'm going to use 1/4 x. And I know to multiply because of the word of. A fourth of the money is a fourth times x, or if I want a fourth, I could divide by 4. So this is one of the ways that you could write an equation for that statement. Is there another form that we could write it in? What do you think about this equation? X is equal to 1/4 x plus 6. Pause the video and think about if that would be an equivalent equation. If you were thinking that those are equivalent equations, you are correct. You could start with a fourth of the amount he has and then add 6, and then that would give you the total that Paulo started with. So either one of those equations would actually be correct. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. Let's start by defining a variable. It says when a fraction of 57 is taken away from 57. Let's let x equal the fraction of 57. So this will be represented by x. When a fraction of 57 is taken away from 57, well, would that be 57 minus x or x minus 57? If it's taken away from 57, then you start with 57. What remains? That is our equal cue. What remains exceeds 2/3 of 57 by 4. Well, how would you write 2/3 of 57? Remember that of means to multiply. So we want 2/3 times 57. 2/3 times 57. Now, are those equal? No. It says that what remains, and remember this is what remains, exceeds the amount by 4. So they're not equal, it exceeds. So where does the 4 belong? Does it go on the left side of the equation or the right side of the equation? If we know that what remains exceeds, that means that this amount would be bigger. So we would need to add 4 to this side of the equation, the right side of the equation. So we are going to add 4. So now let's read through the whole equation and see if it makes sense. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. And we know that exceeds means it's going to be bigger, so we're adding 4. So this is our equation that matches the written description. Example 4. We want to express the following statement using symbolic language. The sum of 3 consecutive integers is 372. So we know that this is going to be a sum, so we're going to be adding. 3 consecutive integers is 372. So we've got our equal Q as well. Let's start by defining our variable. Let x equal. Now, we're going to have 3 consecutive integers, and remember that we have not solved equations yet using different variables. So we can't use a variable for the first number, a different variable for the second number, and a third variable for the third number, because we don't know how to solve equations using many variables yet. So we'll write this in terms of the first number. So we'll let x equal the first consecutive number, or rather just the first number. The sum, so we're going to be adding them together. So we'll have the first number plus the second number plus the third number is going to be equal to 372. X is your first number. Remember that consecutive numbers, that means in a row. So let's just say, for example, that the first number was 4, then the next number would be 5, and the next number would be 6. If our first value is x, how much more is the next one? Well, it is 1 more than the first. So our second number would be x plus 1. Then our next number is 1 more than this one. So that would be x plus 1, which is x plus 2. Does that make sense that if x is your first number, that the second, or rather the third number, would be 2 more than the first? So our first number is x. Our second number is 1 more than that, and our third number is 2 more than that. So there's our equation. The sum of 3 consecutive integers is 372. Example 5. We want to express the following statement using symbolic language. The sum of 3 consecutive odd integers is 93. Let's review what odd integers, consecutive odd integers, are. Let's say, for example, that the odd integers were, let's just say 9, 11, and 13. Your first integer would be called x. Your second integer, in terms of x, is how many more? It is 2 more than the first. And then your third one, in relation to x, how much more is the third number than the first number? Well, 13 is 4 more than 9, so 4 more. So this is your first odd integer. This is your second consecutive odd integer. And this is your third consecutive odd integer. And you have to be careful on this because sometimes you might get confused that we're talking about odd integers, but you have even numbers in your equation. All right, so back to our problem. The sum means that we're going to add. We need to express or define our variable. Let x equal the first number. So the first number is x. The second number is x plus 2. And the third number is x plus 3. So there are your consecutive, not x plus 3, x plus 4. Those are our consecutive odd integers. That's our equal cue, 93. On your own. The sum of 4 consecutive even numbers or even integers is negative 28. Pause the video and write your equation. Remember to identify your variable first. The sum, so we're going to be adding them together. 4 consecutive even integers is negative 28. So we know that this is going to be equal to 28. You want to be careful with the word is. It doesn't always mean equal to. In this case, it does. Okay, consecutive even integers. So x is our first even integer. Our next even integer is 2 more than the first one. Because remember, even numbers vary by 2. For example, we have 20, 22, 24, 26. So these are 2 apart. Then, compared to your original number, the next one would be 4 apart. So our next even number would be x plus 4. Our next even number is 6 apart. So we have x plus 6. So this is the first number, the second number, the third number, and the fourth number. So we need to move over, that's all we needed. And that is equal to negative 28. Now some people might simplify this and combine like terms. So here you have x, 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 and x all added together. So you could say 4x. And then you can combine your constants, 2 plus 4 plus 6, and that would give you 12, is equal to negative 28. These are equivalent. The second has just been simplified. Number 2, a number is 4 times larger than the square of half the number. Pause the video, identify a variable, and then try to write your equation. Here are 2 ways you could solve it. The number is 4 times the square of half the number. So you can take that number and divide it by 2. Or you could say the number is 4 times the square of half the number. Both of those would be correct. Remember when it says 4 times larger that you're multiplying by 4. Number 3, Stephen has some money. If he spends $9, he will have 3/5 of the amount he started with. Pause the video, define your variable, and write your equation. X is the amount that he starts with. He spends $9 and he will have 3/5 of the amount he starts with. 3/5 times X. Number 4, the sum of a number squared and 3 less than twice the number is 129. You may need to read the problem a few times. Read it again, define your variable, and write your equation. We'll let x be the number. Then it says the sum. Well, the sum of what? The sum of a number squared. How do you write a number squared? If x is the number, then the number squared would be x squared. The sum of the number squared and what? And 3 less than twice the number. 3 less than twice the number. Well, how do you write twice the number? 2 times the number. How do you write 3 less than that? You start with that, 2x, and you subtract 3. Okay, let's go over this. The sum, so here's the sum of what? A number squared, that's x squared, and 3 less than twice the number. This is 3 less than twice the number. Is, that's your equal sign, 129. The number squared and 3 less than twice the number is equal to 129. Number 5. Miriam read a book with an unknown number of pages. The first week she read 5 less than a third of the pages. The second week she read 171 more pages and finished the book. Write an equation that represents the total number of pages in the book. Read through the question again. Choose a variable, what it will represent, and write an equation that matches this statement. Okay, don't look at the answer until you've tried it. I'm going to let x be the total number of pages in the book. The answer is 1/3 x minus 5, all added to 171, and that equals the number of pages in the book. Okay, so it says the first week she read 5 less than a third of the pages. So this is 5 less than a third of the pages. Remember, of means to multiply. The second week she read 171 more pages. So we add 171. This represents the first week. This represents the second week. Then she finished the book. So we know that that is the total number of pages in the book. In this lesson you have learned, begin all word problems by defining your variables. State clearly what each symbol will represent. Written mathematical statements can be represented as more than one correct symbolic statement. Break complicated problems into smaller parts, or try working them with simpler numbers.